This video is going to give some hints and tips for the first integration assignment for this week. I'm going to go through most of these, but some of them have quite trivial steps. If you need further help, then feel free to drop me an email. So, question 1 is quite an elementary integral, apart from the first one, which goes to a special case. So you're firstly finding the antiderivative first of all. Then you're doing this definite integral from 4 to 9, giving your answer in that particular form, and then m, n, and p are rational numbers. I'm going to leave that one for you to do. Question 2, we've got this quotient in our integrand, e to the 2x over e to the 2x minus 1. Now the minus 1 is causing the most amount of difficulty here, but you'll notice that the form of this integral is of the form f dash over f. Okay, so that gives you a bit of a clue as to how to proceed. However, there's 8 marks to be got for this, so although this can be done almost by inspection, I think your best course of action is to do a U substitution. Because that will give you enough working out lines for you to get full 8 marks, because if you just do it straight away, you're likely to lose marks in the real exam. So U substitution is probably the best way to go. I'll leave it to you to think about what you're going to make your U substitution. And then we're equating this definite integral to ln of 4. So we then have to use your upper and lower bounds with ln b to work out what the value of b is. And I'm presuming at some point you're going to be needing to use some log rules in order to combine logs. So we're expecting something like this at the end. Oops, sorry, that's going to be a 4, isn't it? ln of 4. So I would imagine that's going to be the end of your question, and then you can compare what's inside the natural logs. Right, question 3, we're integrating cot of 3x. The identity to use for this is to consider cot to be a quotient, and then you can use a straightforward integration rule to integrate that quotient. Don't forget as well what's going to happen to the 3 when you differentiate your answer back again, so just bear in mind that there might be something extra in terms of steps. For cos squared of 6x, for question 4, you're going to be wanting to turn this power of cos into some alternate form using an identity. I'll leave it to you to look back through your notes and think about which one that's going to be. And again, just like the previous question, think about how the fact that it's 6x is going to change your answer, and you may want to differentiate your answer back again to check that it makes this again. Question 5, another definite integral question, which looks like something to the power of 4. We're putting bounds of a and 4 in, and we're getting an answer of 211, and we want the value of a. So not a particularly difficult integral to do. If you think about what form of function we've got here, this is basically a function of x, and then it's to the power of 4. So you might want to try something sensible, and then adjust for some constants, I would say. So try something sensible. Something that you think would roughly differentiate back to this again. Okay, or if you're stuck, then U substitution will help you out as well. Okay, it's normally quite clear what the U substitution is going to be for this case. And then do some form an equation, take away, and then equate it to 211 over 10 and see what a is. Question 6. So this is using what looks like a angle sum formula there for cos of 7x, which is the same as cos of 5x plus 2x. And this one as well, using the angle difference. And then if you can get that to something nice, you can then possibly integrate this by writing it in an alternate form. Okay, it'll be up to you to look up the angle sum and angle difference formula there for cos. Question 7, we've got another definite integral. Bear in mind any calculus problem is going to involve radians rather than degrees. So you've got to make sure that your calculator's in degrees mode. That your calculator's in radians mode first of all. Then we've got sine of 4x next to 1 minus cos 4x, and that's all cubed. So I'm comparing what I've got at the front here to what's in the bracket, and it looks like we've got an integral of the form f dash of x times a power of f of x. So that's the form of our integral, which then gives you something sensible to try. And again, you're going to be testing out your derivative and then checking for any constants that might appear as well. Okay, and then put the bounds in, and then we should be getting some kind of nice exact value for that. And that's 4 marks. Question 8. I don't think we have done the cubes of the trig functions before, but there's a nice trick that I can show you as to how to do sine cubed. I can give you the first couple of steps here. The first couple of steps is to firstly split up your sine cubed into 2 components. That's going to be sine squared of x times another third sine of x. Then I guess you might want to do integration by parts. I think you could probably get an integration by parts to work on this. However, if you want to proceed in the way that I would do it, I would then change sine squared into 1 minus cos squared. And then this bracket expands into 2 separate terms, which you can then integrate separately, one of which is going to be straightforward, and the second of which is going to involve a further technique, which is going to be this portion here. So think about how you might deal with integrating that term there. And that's 4 marks. Finally, question 9, we're showing the identity first of all. Now it turns out you can do this in either direction, and it doesn't particularly matter which way. You can go left to right with this identity, or you can go right to left. I'm imagining that most of you will be wanting to sort out the right-hand side because there's more going on. But if you want to go left to right, you're going to be wanting to do something similar to question 8 in splitting up this power, like this, and then using further identities to get sec squareds out of all of this and turn it into the right-hand side. If you want to go backwards, you're going to be using some identity that links sec squared with tan squared. I'm sure that if you look back through your notes, you'll be able to find that one. For part B, we're then finding the exact value of tan to the 4 from 0 to pi over 4. Clearly that's going to be, seeing as it's a hence question, we're going to be using the right-hand side of this identity. So we're going to be changing this. And then each of these 3 terms that we're integrating is going to involve a separate technique, and I'll leave it to you to figure out how to integrate those 3. And that's 5 marks. Okay, hopefully that gave you a bit of a hand with some of those. If you have any more questions, obviously as well, I'm free by email, and that's going to be giving you a mark out of 50. Okay, thanks very much, Year 13. See you soon.